we're going to talk about least squares regressions. First, we're going to talk about some vocabulary. The first vocabulary word is linear model. A linear model is one variable as a linear function written in the form f of x equals mx plus b of another variable. Interpolation is estimating a value between known values of data. Extrapolation is estimating a value beyond known values of data, and residual is the observed value minus predicted value. It can be thought of as the error. Example. George emphasized that the price of a diamond is determined by cut, carat weight, color, and clarity. The table at the right gives carat weights and approximate prices in US dollars for 20 rings sold at a recent auction in Singapore. All the rings are the same quality gold and contain a single diamond. So we have the table and we have our graph. The linear model is based on the weight of the diamond used. Although the data are not collinear, the line through 0.18, 600 and 0.32, 1400 seem close to the points. It has been added to the graph. An equation of the line is one linear model for these data. Is the size alone a good predictor of price? For part A, we'll find an equation of a graph line which relates weight and price. So first we need, for part A, we need to find our slope. So we're going to do 1400 minus 600. So that's our y1 minus y2 all over 0.32 minus 0.18. So for the top, we have 1400 minus 600, which gives me 800. All that over 0.32 minus 0.18, which is 0.14. And 800 divided by 0.14 is 5,714.29. Now we're going to put it in slope intercept form. So remember that's just f of x equals mx plus b. So we already know our f of x, we can use either point. So f of x is just the same y, by the recall. So we could write it as, let's say, 1400 equals 5714.29 parentheses 0.32, and that's using this coordinate. And the slope. So all we have to do is multiply and subtract and find our slope now. Or sorry, y-intercept. 5714.29 times 0.32. This gives me 1400 equals 1828.57 plus b. I'm going to subtract 1828.57 from both sides. And we end up with B equals negative 428.57. So this gives me my equation as y equals 5714.29 x minus 428.57. And there's the equation of my line, and we're done part A. Part B, interpret the slope of the line in the context of the problem. So our slope was 5,714.29. So for part B, is what we can say. The price of the diamond increases by $5,714.29 for each carat weight it increases. And we're done part B. Part C, use a model to estimate the price of a 0.3 carat diamond ring and determine whether this interpolation or extrapolation. So for part C, we're being asked to do is find the y values. So we're going to say y equals 5714.29 parentheses 0.3. We're plugging in 0.3 minus 428.57. Use a calculator for the rest. 5714.29 parentheses 0.3 minus 428.57. And we end up with 1285.72. And if we look at our original data, we see prices that range from 0.18. You do have some around 0.35 and 0.33. So because this is in between the data sets, we're going to say this is interpolation. D, use the model to estimate the price of a 0.45 carat diamond ring and determine whether this is interpolation or extrapolation. So just like in part C, all we have to do is plug in 0.45. Let's say y equals 5714.29 plus 0.45 minus 428.57. Use a calculator from here. 5714.29 parentheses 0.45 minus 428.57. When I type that in, I get 2142.86. Now we got to answer whether it's interpolation or extrapolation. Determine that, we look at our original data. We have 0.18, we have 0.7 to 0.20s, 0.35, but nothing past 0.35. So this is outside or beyond the data set. So this is extrapolation because it's outside. And let's make that clear from the last one. This is inside the data. Part E. Why is the model not good for predicting the cost of a 0.05 carat diamond ring? So to figure that out, what we need to do is plug in 0.05 into the equation, find out what we end up with. 5714.29 parentheses 0.05 minus 428.57. So 5714.29 parentheses 0.05 minus 428.57. And we end up with a negative number. Negative 142.86. So that's saying, this says the cost is negative, which doesn't make sense. In other words, I'm paying you to take a 0.05 carat diamond off my hands, which I want to make money, not give you a diamond plus give you money on top of it. So that's why it doesn't make sense to, this model doesn't make sense for the 0.05 carat diamond. F. Why is the set of data not a function? So let's look at the original data and see what we have going on here. So we have 0.18, 0.17. Let's see what we have repeating. So 0.18, 0.17 looks like it's repeating. Oh, two different values there. 0.25, 0.29, 0.27, 15, 20. Oh, 25 repeated. 21, 35, 33, 26, 16, 16's repeated, 15's repeated, and they take note, these all have different prices. 0.16 repeated 3 times. So we have numerous diamonds that have different costs. So for that reason, it's not a function. So we could say 0.17, I believe, 0.15, 0.16, 0.25. Let me make sure I have those right. Yes. All have 2 or more price values. And we're done explaining why it's not a function. And then part G, calculate the residual for a 0.16 carat diamond ring. So first we need to find the value of the function. So it's 5714.29, parentheses 0.1. So 16 has more than one value. Let's change that to one that doesn't have multiple values. Let's do the 0.23. Since that only has one value. Minus 428. So we have 5714.29 parentheses 0.23 minus 428.57, and that gives me 885.72. Now, when we're defining a residual, recall the definition is observed value minus predicted value. So we look at our observed, that's 829.50. So we want to do observed minus predicted. What we just calculated was our predicted, so we're going to do 829.50 minus 885.72. And we have a residual of negative 56.22, meaning the price is $56.22 lower than predicted. And we're done.